In this lesson, we're going to configure an Arista switch to run in tap aggregation mode. Be sure to check out Arista's configuration guide, transfer of information documents, and the EOS Central website for documentation regarding this feature. As a reminder, the tap aggregation overview lesson, Arista's tap aggregation feature provides us with the device that can receive tapped or mirrored packets and then steer them to a tool or a suite of tools. You may have heard of this type of solution referred to as a tools concentrator or network packet broker. Arista's tap aggregation feature is extremely easy to set up, and it provides us a way to accommodate requests from security teams or application owners with tools to analyze packets for security or performance reasons. Arista's tap aggregation feature helps us overcome the often bumped into limit of network taps or switch mirror ports. Here's a picture to help you visualize the role the tap aggregation device plays in the network. As you can see in this picture, we can have network taps or mirrored ports from our production switches connected to a switch running in tap aggregation mode. The purple boxes indicate tap ports, and the orange indicates our tool ports. And as a reminder, our tap ports only ever receive, and our tool ports only ever send. There are specific Arista platforms that support the tap aggregation feature. Currently, those are the Arista 7150s, the 7280s, and the Chassis Solution 7500E models. The first thing we'll do is place the switch into tap aggregation mode by entering tap aggregation in global configuration. I want to take a look at the interface status currently. So if I use the command show interface status, enter, we can see that this switch has 24 ports and they're in various states of either not connected or connected. We go into config mode and then tap aggregation and enter. And here we'll enter mode exclusive and enter. Immediately, we're prompted with a warning that changing modes will restart the forwarding agents and may affect available functionality. Unsupported configuration elements will be ignored. Now, if I get out of configuration and show interface status, we'll see that all of our ports are now in air disable. When running the switch as a tap ag device, the interfaces can only be in either tap mode or tool mode. An interface not configured as those options is placed in air disabled state by default. Notice that we use the exclusive mode. For some platforms, there is the concept of a hybrid option. Be sure to check the most current documentation specific to your model and EOS version for more details. Let's drop into our interfaces and configure one for tap and one for tool. So config, enter, interface, Ethernet 15, enter, and then switch port mode. If we hit question mark here, we're used to typing in either access or trunk, but because we're in tap aggregation, we're going to use tap or tool. So here I want Ethernet 15 to be a tap port. Now, if we look at our configuration for verification purposes, show run interface Ethernet 15, enter, we see that interface Ethernet 15 is in switch port mode tap. Let's configure an interface to be a tool port. Let's use interface Ethernet 23, enter. Here, instead of switch port mode tap, we're going to do switch port mode and then tool and enter. And then verification, show run interface Ethernet 23 and enter. And we see interface Ethernet 23 is in switch port mode tool. Tap ports and tool ports allow all VLANs by default. If we want to exclude or specifically include certain VLANs on either our tap or tool ports, we will use the following commands. Interface Ethernet 15, enter, and then switch port trunk allowed, VLAN none, enter, and then switch port trunk allowed, VLAN, and we'll add 1 through 10, so 1-10, enter. And then show run interface Ethernet 15, and in the output, we can see our switch port trunk allowed VLAN 1 through 10. We'll do the same thing on our tool port. Interface Ethernet 23, enter. Switch port trunk allowed VLAN none, enter. And then switch port trunk allowed VLAN add 1-10, enter. And verification, show run interface Ethernet 23. And we see our switch port trunk allowed VLAN 1 through 10. Now that we have one tap port and one tool port, we need to map traffic received on the tap port to be transmitted on the tool port. There exists the concept of groups, or more specifically, aggregation groups. Groups serve as a mapping between tap ports and tool ports. By leveraging groups, we can easily map the traffic through the switch from the ingress, or tap, to the egress, or tool. Let's assign both our tap port of Ethernet 15 and our tool port of Ethernet 23 to group foo1. Interface Ethernet 15, enter. Switch port, tap, default, group, and then we'll call it foo1, enter. And interface Ethernet 23, enter. Switch port, tool, group, set, foo1. So you can see the commands are slightly different between a tap port and a tool port, and hit enter. For our verification, show run interface Ethernet 15, enter. And we see our switch port tap default group foo1, and show run interface Ethernet 23, enter. And we see our switch port tool group set foo1. We can also issue the command show tap aggregation groups and hit enter. And we'd see our group name and our tool members and our tap members. The only reason that they're in none at this point is because I actually don't have anything connected to those interfaces, so they're not in operational status. So to keep this lesson a reasonable length, we're going to stop here for now and pick up in another lesson to go over the other tap aggregation configuration features such as identity VLAN, truncation, and traffic steering.